Welcome. We now come to another concept of mathematical tools, which is binomial theorem. Well, to begin with binomial theorem, we'll start with a very small piece of mathematics which you already know. Say, for example, I ask you, what is 1 plus x whole square? Your answer is, well, it is 1 plus 2x plus x square. Now I go on to ask you, what is 1 plus x to the power 3? So then you tell, sir, it is a formula from algebra where I can say it is 1 plus 3x plus 3x square plus x cube. So in these two equations that we have right now, what we can see here primarily is that the number of terms involved here is just one more than what we have as a power here. And then the same here also, we have 1, 2, 3, 4 terms, and your power is 3 here. And the second thing that we have is, if I consider this quantity to be very small, then what eventually happens is that if you say, for example, I'm squaring 10. Now what is 10 square? You say that it is 100. Now if I square 0.1, then you can see that the value eventually is much less than this one. So what I have here is a big figure. If I square it, it becomes even bigger. But if it is small and I square it, it becomes even smaller. So now what we do in binomial is we put these quantities x very small. So these quantities, as you can see, x square, or in that case 3x square, x cube, they are too small to be considered. As they are too small to be considered, what we do now is we say that, well, we neglect them. So now what happens to 1 plus x whole square? So now this is what is remaining of 1 plus x whole square. It is 1 plus 2x. What happens to 1 plus x whole cube? Well, what remains of it is 1 plus 3x. So I hope you have already got the logic that all you do is multiply the power here. All you do is multiply the power here. So now I go for a generalized case of 1 plus x to the power n. And I hope all of you will be able to answer that it is 1 plus nx. Now if I ask you, well, what is 1 plus x to the power minus n? Then I hope all of you will understand that it is 1 minus nx, nothing else. And now in the similar way, we go on to do some more things like this. Say, for example, I'm asking you what is 1 minus x to the power minus n. So that is again 1 plus x. Why nx? Because minus and minus makes plus. And then if I ask you what is 1 minus x to the power n, and it is, 1 minus nx. So these are the primary things what we do in binomial, and this is a part of what we call mathematical induction. So that is a variety which you learn in mathematics, and in simpler terms, here you learn in binomial. Now let us see that how this we can be applied for physics. Now let us see that how we can apply this for physics. Say I ask you the relation between density and temperature. Well, for that we begin with a relation between volume and temperature. As you know that volume is nothing as it goes on increasing with temperature. So I have a coefficient here called gamma. It is simply a constant, nothing else. Don't worry about this constant right now, because simply consider this as a constant. You can name it gamma, you can name it k, a, b, whatever you like. But try to get to the other part of this story where we say that what is volume? Well, it is mass by density. So here also we have mass by density, but the density is that of initial. So it is V0, correspondingly rho 0, and what we have here is 1 plus gamma t. Now, children, what we have here is something like this, that rho 0 is rho 1 plus gamma t. But you see, what we require is not rho 0, but we want to know what is rho. So if I want to know what is rho, then I should write it right now like this, that rho is nothing but rho 0 1 plus gamma t goes to the denominator. Now I apply a simple logic of surds and put it 1 plus gamma t to the power minus 1. And then what I do here, I apply binomial. So it is rho 0, 1 minus gamma t. So I hope you understand the whole situation now, as in case of volume what we had is that with rise of temperature, the volume increases. And as volume increases, density should decrease, and here we have why it is decreasing, because it is having a minus sign here. So this is how actually we are applying the binomial theorem in case of physics. Now I will give you one more example to make it more simple. You see, I have a relation between acceleration due to gravity which goes something like this. Please don't try to get into the nitty-gritty of the equation, but try to get to the portion of binomial which is involved here. So if I ask you that what should be the situation as I put it here as a whole of square, and if I put it here as 2, then you will get right this. What is g? It is 1 plus h by r, and the power gets minus 2. The moment the power gets minus 2, it comes to 1 minus 2h by r. So this is how again we have used the binomial, the minus power here, and this makes it 1 minus 2h by r. So the binomial, you can see, is a very simple methodology that we are applying to understand physics in a better way. Thank you.
For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.